today we start with the chemistry and continuously lecture series, and that is one of the good video presentation by me, and that is the isomerism in organic compounds. So all of you are well known about that the chemicals are responsible for different technologies, even most of the polymers which are related with the organic compounds. So today we discuss about the isomerism in the organic compounds. All of you are well known about that. Organic compounds are what are those containing carbon compound. However, there are a number of certain differences between the inorganic and organic compounds. What are the major differences between the organic and inorganic compounds? So we have to continue for that. Organic compounds are mostly the catenation product of the carbon atom. The simple definition of organic compound is the hydrocarbon and its derivatives with the nitrogen, as well as with the sulfur, as well as with the phosphorus, as well as with the oxygen. So number of functional groups are achieved with the combination of oxygen. For example, carbon combined with double bond oxygen, and that one is the carbonyl compound. So let's say we have to see why such functional groups are achieved. Here we can say the different organic compounds having a number of functional groups. So we have another concern is also that the carbon atom, which is one of the exceptional element, and having because of the exceptional element, and due to that, certainly carbon compounds are more and more at this present time. About 70 lakh organic compounds are there, and those contains the carbon atom. So element carbon, the electronic configuration, all of you are well known about the electronic configuration of carbon, and the electronic configuration states 1s2, 2s2, 2p2. So whatever in case of the periodic table, when we have to go to from left to right, and in that particular concern left to right, we have the carbon is present in the group, and that whole group, that a group is of the so we have to see 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 and 18 groups are there in a periodic table. So let's one group first group, one group, two group, three group. So from 1 and 2, those are alkaline earth, and from 3 to 12, those are the transition metals. Then we have the 13 and 14. So this is containing 14 group, and which can be stated that there are the 4 electrons are present, and this is the tetravalent. Now the hydrogen and carbon combination. In that particular case, the carbon combined with 4 of hydrogen atom, because the hydrogen itself is monovalent. When this carbon combined with oxygen, so whatever that particular oxygen, in a period number 2, carbon, then nitrogen, and then we have the oxygen. So oxygen itself is the divalent. Nitrogen also combined with the carbon atom. So carbon and nitrogen both can be combined with each other. So here number of organic compounds are formed because of the trivalent nitrogen and divalent oxygen. So here one more thing is there. What we have, these are the chain compound, long carbon chain. So the meaning of long carbon chain, that they can having why the carbon itself combined with another carbon. So therefore a long carbon chain can be formed. So that is particular hydrocarbon chain, and in which, if suppose we have the only carbon and hydrogen, in that particular case, there may be the single bond and as well as carbon double bond carbon, and one more carbon triple bond carbon may be there. So holy hydrocarbons having a number of compounds. Now one more thing is there, carbon single bond carbon. That one we have to say that saturation is there. So we call that saturated hydrocarbon. Saturated hydrocarbon, the sense where the sigma bonds are there. Here we can also put the theory of chemical bonding, and that was very uh, abstractional command on that particular theory, and that can solve lots of chemical bonding. So here we see the carbon-carbon bond, that is the if that is there is the sigma bond, the carbon single bond carbon. So let's say one more thing is there, and that is the easily we get the linkage with other carbon. So this property is called the catenation. So what about the meaning of catenation? Because one carbon combined with other and then the formation of the get long chain compounds. So therefore it is informative for us that why number of hydrocarbons are there in the present context. One more thing is there, organic and inorganic. Earlier, organic compounds, the definition was that the compounds only obtained from the organose. Organose means the life, and life itself the bios. Bios itself from the plants or from the animal. So earlier this was there that urea, urea itself obtained from the urine. So urine itself is the product of animal. So therefore, urea is called, that is the bio organose compound. But later on, the Waller synthesized that particular urea in the laboratory. So the concept of organose is a little bit down. So later on, the modern definition of organic compound, and that is the simple hydrocarbon, one thing, hydrogen and carbon containing compounds. And in those cases, we have to see then the double bond also, unsaturation also. So hydrocarbon saturated, unsaturated with a double bond. Now, why they form the double bond? This one is also because of the hybridization concept. Here, the hybridization of carbon atom, that can be directly relates whether carbon can link with the single bond or carbon can link with the double bond. So let's we have to show about those particular different organic compounds and their classification. Simple classification, whatever the carbon chain is open chain compounds, and or either they have the formation of the ring. Ring means closed chain compound. So whole chain is closed. So that is in the cycle. If suppose we have to see the four carbon atom form a cycle, three carbon atom form a cycle. So that is the cyclic compound. So let's we have to discuss about all those cyclic compounds and the alicyclic. Ali means whatever those related with the fats. So here we open chain compounds and closed chain compounds. Various examples. Open chain compounds, examples, simple one, ethane, two carbon atom, hydrocarbon, three carbon atom, propane, then four carbon atom, butane, and five carbon atom, the pentane. So these are the open chain compounds. When we have to make the cycle of these different carbon atoms, and that particular cycle is called the cyclic compounds. So whatever there is a major difference, these are open and these are the closed chain. So this is one of the basic classification of organic compound, and that classification of organic compound itself is concerned and based on the fundamental things, that is the catenation process. So let's we have to continue about the isomerism. Isomerism itself, that can be, can say that here, uh, the organic compounds we have already discussed. The aliphatic compounds. Aliphatic means ali means the fat. So here aliphatic compounds are also there. Then we have the aromatic compound. What are the concept of the aromatic compound, and that is the producing of the aromas. Aromas, a special type of smell, special types of fragrances are given by aromatic compound. Simple example is the aromatic compounds are the one number of compounds are there, but we have the benzene. Benzene itself is the cyclic compound, but in case of the benzene, three double bonds are present in a cycle, and their shape is hexagonal shape. Hexagonal shape of the benzene. So here the aromatic compounds are the benzene and its derivatives. What do you mean by the derivatives? That those the free carbon valencies, those linked with the hydrogen, can be substituted with another uh, derivative, another moieties, whatever the methyl, so that become the methyl benzene. Methyl benzene itself is the toluene, and then we have to substitute one more methyl to add. So therefore, the dimethyl benzene. Here, one more thing is there. In case of the dimethyl benzene, there is certainly whatever we have the benzene ring and those methyl group. Methyl group is what? That is obtained by the CH4. CH4 itself is methane, but if one hydrogen is free in methane, and that become the methyl group. So methyl group when attached to the benzene ring, and that will be the methyl benzene. So therefore we have to see the methyl benzene, and then because six carbon are there in a benzene ring. So therefore if another CH3, the methyl group is attached at the second position, there may be whatever the even the methyl group go to the third position. One, two, three, four, five, six. That is the benzene. So in case of the benzene, one is the mono substituted and substituent is the methyl group. Then if two substituents are attached to the benzene, so that become the di-substituted benzene, and that will be definitely 1, 2. So 1, 2 dimethyl benzene. And another way, there the methyl substituent can go to third position. So therefore 1, 3 dimethyl benzene, then 1, 4 dimethyl benzene. So these are the number of aromatic compounds. However, if suppose we have to link the ethyl group. So what is the ethyl group? That is ethane. Ethane is two carbon atom saturated hydrocarbon. So C2H6. This is the condensed formula of ethane. So now we can say the structures formula of ethane, that one carbon, one carbon, 3 CH3. So this is CH3, CH3. If one hydrogen of out of six hydrogen is free, the bond is free, and that particular group is called the alkyl group. Alkyl is the class, and where because two carbon atoms are there, so that become the ethyl group. So here, if suppose we have to attach one of the ethyl group over the benzene, and that become the ethyl benzene. So what we have to see in case of the 1,2 dimethyl benzene, 1,3 dimethyl benzene, 1,4 dimethyl benzene, that is for the di-substituted benzene. So let's we have number of aromatic compounds and those, and then further the naphthalene. All of you know about the naphthalene balls, and naphthalene balls itself are the moth resistant. Moth resistant means those repel so many pesticides. So whatever in this particular case, we are using the naphthalene ball to protect the woolen cloth. So naphthalene itself is also like a benzene but bicycle. So in that particular case, two cycles are condensed, one benzene and another benzene both condense with each other. So therefore, this one is called the cyclic but bicyclic. Bicyclic and condense. So condensation is there between the wall is the same for two benzene. So that one is called the naphthalene. Further, we can say that even more of aromatic linkage are there, and that will be definitely, and we can say the anthracene, one of the most, the other one. So here, anthracene having the three, and naphthalene having the two. So here, number of organic compounds are formed in case of the aromatic compounds. Here, other also the aromatic compounds which there is the that will given in my the expert presentation of the aromaticity in the organic compound, and that we have to see the aromaticity in organic compound that will relates with the Huckel's rule 4n plus 2. So that is the concern of the whatever the unsaturation, and because of unsaturation, but here in benzene ring, special characters are appears. So those special characters exhibits their aroma. So aromatic compounds are generally benzene and its derivatives. Various example. If suppose hydroxy group is connected with the benzene, that become the hydroxybenzene. Amine group is attached to the benzene, that is aminobenzene. Now the next one we have to see after aromatic the heterocyclic. So what are the heteros? Heteros means the different. What is the different? If we have the carbon 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 cyclic compound, for example, if we have the 6 carbon cyclic compound, 1, 2, 3, 4, 5, 6 carbon, and that is the cyclo and hexane. One thing. Then cyclohexane, if they are, then we have the cyclohexatriene, that is the benzene. Now, the one of the carbon itself is tetravalent, is substituted in a ring by nitrogen atom. So, whole cycle itself is of the carbon compound. So that is the homocyclic. But in case of the heterocyclic, one carbon may be substituted by one of the other elements. And here the most one, nitrogen, oxygen or sulfur can be substituted. So those are the heterocyclic compounds. Cyclic and one of the heterocyclic. So very well known example, all of you know about the pyridine. Now the question is there, the natural products are also relevant with our life. And what are those natural products which we get from the nature? And these are also the part of the organic compounds. So we have to see the organic compounds in which the natural products. All of you well know. We eat the food and food constituent. So the major constituent of food, the carbohydrate, another maybe the fat. Okay. Then we have the proteins. So protein, fats, and carbohydrate. These are the natural products. So when they given out by the nature and called the natural products, certainly those are also the organic compounds. But there there may be number of organic compounds and number of carbohydrates, different types of carbohydrate, whatever we can see, the different plants, different animals. Now the question is there, why these natural products are responsible for the life organelles. What was the meaning? Organelles means the life. But how we can say that particular organism means the plant and animal is living? How we can say? So which power is responsible? Which energy is there by which the life is there? So that is the game, that is the plan of the chemicals. So how the life appears in respective plants, in respective animals. So that is the great challenge for us, and we can still not identify that what is the life. But life itself is the process, and where the various techniques are involved, and the number of organic compounds can give a certain values, and that is the life. So, but that is unknown at till now. So life full compounds are the organic compound. So natural products are also whatever we have to discuss about these. So now we have to the isomerism. So in case of the isomerism, whatever I am describing here, two or more compounds having the same molecular form, but they differs. Why they differ? We have discussed about earlier whatever the things, the catenation in carbon atom, the double bond, the triple bond, the single bond, and their links with oxygen, linked with the nitrogen, linked with the other phosphorus, so linked with the oxygen. So here one more thing is there, because of the catenation process, number of organic compounds are formed. Whatever, suppose we have the six carbon atom hydrocarbon. So that is 1, 2, 3, 4, 5, 6 carbon. Now these six carbon atom in a state, that is the hydrocarbon, saturated hydrocarbon. So therefore the carbon and hydrogen. So here the alkane. Alkane is which one? Six carbon atom linear. In this particular case, the carbon itself is 6, and hydrogens are the 6 into 2, 12 plus 2, so that is 14. So carbon 6 and 14. This is the molecular formula of hexane. But you can think about that. Because of the catenation process, 6 carbon in a line. If suppose one carbon of the end of hexane is bragged and linked at the second carbon atom. So such process, such mechanism is the isomerism. And isomerism, the question, the same molecular form, but differ in the structural ways or their orientation. What was the, can we can define those that there are the same molecular formula, but structural formula differs. So what is that? So therefore they exhibit the process is the isomerism. So what about the significance of isomerism? We get the number of compounds. So normal hexane, isohexane. In case of the isohexane, the methyl group attached to the carbon atom, but that is the state chain is of only 5 atoms. State chain is only of 5 atoms. The 6 atom goes to second position. So therefore, the branch will be there. So why we get certain different compounds having the structural formula differs. So that is the that type of isomerism is the chain, and we can also elucidate the position. position isomers, if suppose the methyl group in six carbon atom where the five are straight, so that is the position of the methyl group is at the second carbon atom. So if that CH3 group is substituted at the third carbon atom, so that will be the positional isomer. So this one is the excellency in the isomerism itself, that they have number of isomerism, and one more thing is there. All those isomerism are specific. Whatever the specific, because their boiling point also differ. However, their molecular formula is same, but that having the different structure and different compounds. Whatever I can give one of the example, five carbon atom hydrocarbon. One, two, three, four, five carbon atom hydrocarbon. Very simple. Saturation, carbon 5, hydrogen, whatever the 12, because each carbon atom is satisfied with the monovalent hydrogen atom. So therefore carbon 5 and hydrogen 12. So carbon 5 into 2 is the 10 plus 2 CnH2n plus 2. This is the alkanes and 5 carbon atom. Now the question is there, because of the specific property of the carbon, and specific property is which one? That is the catenation process. So because of catenation, they form their the chain isomers. So because of that, that become mono substituted butane, four carbon, and then one CH3 group attached to the second. Now there is third answer is also there for C5H12, carbon 5, hydrogen 12, single bond, monovalent, hydrogen, carbon itself is 4, that is tetravalent, and each carbon atom is linked with the single bond. But here the third isomer is also present in case of the normal pentane. So first is the normal pentane, second is the isopentane, because the CH3 group is attached to the second carbon, and third is the neopentane. So in case of the neopentane, what we have? The three carbon atom, and then one is the CH3 above, one is so five carbon atom molecule, but structure is different. So those are called the so each of other is are isomers with each other. So pentane, the saturated hydrocarbon, where the 5 carbon and hydrogen atoms are 12, and this activates the three different compounds having the different boiling point, different melting point, different very very different size. So that is the physical characteristics differs in that particular way. So that's why they are the different compound. However, molecular formula is the same, but they differ in the different ways, and this is the way, and those ways called the isomeric. So here we have to continue, and that the classification of isomerism, and here the two different types of classes of isomers are there. The first one is the structural isomerism, and then second one the stereo isomerism. So stereo means the spatial, whatever that particular is the geometrical and optical isomerism. In case of the structural way, whatever we have discussed, and these are also of the six types. What are those? The first one, the chain isomers are there. Second one, the positional, and third one, the functional. Functional groups differ. The molecular formula is the same. Ring chain, because of the ring modification, whatever the by that particular ring and the modify the metamerism, and then the final the other one is the tautomerism. In case of stereomers, this is the geometrical way, and then the other is the optical way. So here the different isomers we have already discussed. Now we have to come towards the another part. Here the alkanes, whatever those particular groups. So here isomerism in organic compound, all those are the organic compounds and having the different isomerism. Different, what are those? Those particulars are the various compounds. And various compounds are where? Alkanes. Alkanes are what? Carbon, carbon, single bond. Carbon, hydrogen, carbon, single bond. Carbon, carbon, hydrogen. So therefore, we have the alkanes. There is no any double bond in case of the alkane. And alkanes are saturated hydrocarbon. But in alkane, isomerism there. What type of isomerism? Here, the simple chain isomers are there. So every we have to see the number of chains. How many? If suppose the carbon atom numbers are more, then definitely there will be the more and more will be the uh, isomers. So in case of the alkenes, alkenes have also the chain isomers as well as the functional isomers. Why functional? Because we have to see the functional group, and that is the specific, and that is in case of the what we have the carbon double bond. Carbon double bond. Carbons are the alkene, and the isomers with the cycloalkane. Alkenes are isomers with the cycloalkane. Here, stereoisomer is also exhibited, and that is the geometrical isomer. In case of the geometrical isomerism, that is of that cis and trans isomerism, so that is also present in alkenes. Alkenes, whatever the compounds having the double bond, carbon double bond, those are the alkenes. And in case of the alkynes, the alkyne itself and the known, those are the alkynes are the acetylene and its derivatives. So there is the carbon triple bond, carbon, those are the acetylene. Now, other functional groups, compounds, other classes of organic compounds, there is one of the most compound class of organic compound, and that is the acid. So, what do you mean by the acid? That is the acid. That one is of the carboxylic acid. Whatever there may be difference between the carboxylic acid and mineral acid. Mineral acids are the inorganic one. Carboxylic acid, those are related with the organic compound. So here, in case of the carboxylic acid, and that is very simple, this is the formic acid. Later on, we have the 2 carbon carboxylic acid, that is the ethanoic acid. So 2 carbon atom, that is the ethanoic acid, as well as this called the acetic acid. Then we have the 3, 4 like those particular carboxylic acid. And there may be the double carboxylic acid are also, and those double carboxylic acid groups dicarboxylic acid. Very simple example, oxalic acid. So in case of the oxalic acid, one COH is attached with the another COH. So therefore, there is the carboxylic acid. Then certainly the derivatives. So what are those particular derivatives? Whether the carboxylic acid is further substituted. How that can be substituted? We have the acetic acid. So acetic acid is further the hydrogen atom of carboxylic acid is substituted by another methyl group. So that become carboxylic ester. So COR. So that is the derivative. There are also certainly other derivatives also present, and number of derivatives are available for the carboxylic acid derivatives. The simple one, the carbamide, whatever there may be, the anhydrides. Anhydrides means anhydration of the carboxylic acid. That is the removal of one hydrogen molecule from two carboxylic acid. So let's we have to continue the isomerism in the uh, organic compound. So first of all, we have the structure of compounds here. Already we have discussed about the single bond as well as the double bond. So here structural we have already discussed the chain isomerism, the positional isomerism, the functional isomerism because of the functional group varied. Here we can say the functional group varied from carbon double bond carbon, and then we have the cyclic compound, or we have the alcohol and the ether group, then ring and chain isomerism, ring or chain maybe. Then we have the metamerism, and last one is the tautomerism. So these are the whatever the concern of the structural isomerism. Instead of here, we have to come towards the chain isomerism. I have already discussed that the same molecular formula represents two or more compound. It differs in the nature of carbon chain. The carbon chain may be straight or may be the branch. Example is the simple the butane. So carbon, four carbon atoms are arranged, and here we get the two isomers, and one is the normal butane, another is the isobutane. So isobutane having the linear structure is of three carbon, that is the propane, and at second carbon atom methyl is linked. So therefore butane and 2-methyl propane. That is the whatever the name, but all of you know about that. That LPG contains the 3 and 4 carbon atom hydrocarbon. So normal butane and isobutane. Those are the mixture of that, and that is also used in somewhere the whatever the ignition of that particular. Now that we have the position. Position of what? Position means whatever. Where is the position? If we have the 6 carbon atom hydrocarbon. So CH3 position in the 5 carbon atom long chain. So there may be the position at the second carbon atom or at the third carbon atom. Similarly, in case of the hydroxy group, that is the alcoholic group, so the alcoholic group also the position, and double bond having also the position. So position of the double bond, whether in case of the 4 carbon atom, 1 butene, because the carbon double bond carbon is at the one position. In case of 2 butene, the carbon double bond carbon position is at the start from the second carbon atom. Now we have the functional metamerism. Here also, whatever the we here propanoic acid, and propanoic acid itself having the carboxylic acid. So the same molecular formula having the two or more compounds. So those are the isomers. This is very simple compound, and that is the 3 carbon atom carboxylic acid. So what happens in case of the 3 carbon atom carboxylic acid? That is the propanoic acid. So methyl ethanoate, whatever this compound, and methyl ethanoate, where what happens? The carbon double bond oxygen is there, but the shifting of one of the CH3 group towards the other side. So therefore, in this particular case, one side is the methyl group, another is the acetyl group. So therefore, this becomes the new compound, and that is the functional metamerism. So here, double bond oxygen is the shifted. So this one is the part of the functional isomers. Function groups are changed. Now, there are certain other things, and those are related with the whatever we can say, and most of these are also related with the isomerism in the organic compound. So, in this particular case, whatever the other things, and we can say different isomerism in organic compounds. These are the uh, whatever the metamerism, whatever the functional. So different here the answer of the uh, whatever the metamerism, the positional isomers or the chain isomerism, So the correct answer for this is the whatever there may be, the correct answer is the functional isomerism. So here this is because the compound with the same molecular formula but in two forms. One is the alcohol and the other is the ether. So there the type of isomerism that it show, and that is the C1. The answer itself is the functional isomerism. So here we can see the functional isomerism. This is the answer for that, and here also the chain isomerism. Whatever, uh, then correct answer is the C. So we can say that the correct answer itself is the C. There is the explanation for this one, and this explanation exhibit that here we have to see that so uh, explanation functional isomerism arises when two or more compounds. So two or more compounds having the same molecular formula but different functional groups. So this one is the uh, now the next question, that is the acetaldehyde and ethanol. Ethanol. So here you can say the acetaldehyde and ethanol. So ethanol means carbon double bond carbon and hydroxy group. So therefore they exhibit the correct answer is the tautomerase. In case of the tautomerase, there is, and so we can say acetaldehyde, this is CH3, carbon double bond oxygen and hydrogen. This is CH3, CHO. So we can say that particular, there is the explanation for that, that the compound acetaldehyde and ethanol exhibits tautomerism. So therefore, they are tautomeric with each other. A compound acetaldehyde and ethanol exhibits tautomerism. So tautomerism is a special type of functional isomerism and which arises in the carbonyl compound. So what are the carbonyl compound? Where the carbon double bond oxygen is there. So carbonyl compound exhibits, and here the carbon double bond oxygen as well as then that here in the another case carbon double bond carbon is there. So therefore that is ethanol. So double bond and hydroxy group is there. In case of the another, we have to see the another example, and that is in a compound having the 3 chiral carbon, what is the number of optically active isomers? In this particular case, the answer itself is the D. And another question, enantiomers are the same as the diastereomers. That is the question of the stereoisomer. So here the correct answer is the B. We can say the explanation for this, whatever we can say that particular here the optical isomerism enantiomers are the non-superimposable mirror image, while the diastereomers are the isomers which are non-superimposable and not related to each other. Now, here is one of the question related with the D form, and we can say the D form is also known as, this is the dextro-rotatory. So whatever one of the optical isomerism, this is also the type of stereoisomerism. So overall we can say that different organic compound isomerism is exhibited by the different organ. Here we can say the functional groups are also responsible for that. So functional group also exhibit their respective isomerism. So here we can conclude that different organic compounds exhibits different types of isomerism. And here we can say one more question. So all of you are welcome to ask me any of the question. and that can be related with the isomerism. So here um my mobile number is there, as well as email ID that is also there. So anyone can ask me the related questions, whatever that can be. The I will give the answer. So you can also see the website of Suresh Gyanwar University, and here number of programs are available. Different courses for the Suresh Gyanwar University are available. So finally, we can say the different uh, isomeric, what are those? Thus, we can say that are the number of isomeric, the particular in case of the and different organic compound. Here, the various compounds, aliphatic compounds and aromatic compounds, as well as the heterocyclic compounds are involved, as well as we can say the different natural products have also the different isomerism. So this one is the all about the organic isomerism in the organic compound. So anyone, I think, I suppose that you will get the best knowledge from this video lecture series, and hope that you will be more powerful with enjoyment, with enjoying this particular knowledge all about this. So I salute all of you, and you are welcome to ask me any of the question. All the best.